Hello lovelies, in this video we're going to be looking at sampling for your GCSE maths. Now we're going to take you through lots of examples here, work through really slowly, so you're under no pressure from anybody else checking up on you or seeing what you're doing. Just take this at your own pace.
Look at sampling, and what's really important is why we use sampling. So looking at question 1, it says a school has 414 students. Now let's say you want to get the students' opinion on something, for example lunchtime choices, or changing the school day to a longer or shorter break time. You want to know what the students think. Do you ask every single one of the 414 students? Now you could do that, and with a number like that, I think that's practical. But with a sample, you can get a rough idea with a much smaller number of students. In this case, the sample is going to be 41 students, which, as you can imagine, will be much quicker. Now, this really works is much larger numbers. If you want to sample everybody, say, in the country, and we've got, over 70 million people in the country, you can't ask every single person without a lot of time and effort. So a sample is a way to get the opinion of a large group of people by only asking a manageable amount. So for our school, it's 414 students. Now you could get that number by adding up all the boys and girls in each year group, but often the question will give you that number. But it's important to know that if you don't have the total number, you can work it out by adding up all the numbers in the table. Now the way that we sample is that we take the number of students we are sampling 41 students, and we divide it by the total. And what this does is it gives us the percentage of each group we need to sample. So if we do that division on a calculator, we're going to get 0.099 to 3 decimal places. And that's a decimal. And to convert it into a percentage, we can multiply it by 100, and that's going to give us 9.9%. And this is a stratified sample. So what that means is that you don't just ask 9.9% of the students in the entire school, because it might be easier just to walk into year 1, ask all the students in the year 1 class, and then you're done, you've got up to your number. But the opinions in the other classes might be different. So what you want to do is ask 9.9% of every single identifiable group of students. So 9.9% of the year 1 boys and the year 1 girls, 9.9% of the year 2 boys and the year 2 girls, and so on. It just makes your sample fair. Now the question is specifically asking for what is a sample of year 5 boys. So what we need to do is find year 5 boys in a table. So I'm just highlighting that in green. And there are 31 boys in year 5. So how many do we ask out of the 31? So we take the 31, we multiply by the percentage. When you multiply by a percentage, you just multiply it by the decimal version. And so on a calculator, we can do 31 multiplied by 0.099, and that's giving me an answer of 3.07 to 2 decimal places. Now, can we ask 3 and a bit of a student? No, we can't. That's ridiculous. We can only ask whole numbers for people. So when we get our answer, what we need to do is just round it to the nearest whole number. And the nearest whole number, obviously, to 3.07 will be 3. So we're going to be asking 3 year 5 boys their opinion, rather than asking the entire class. So asking 3 rather than 31 is going to save us some time. Moving on to question 2, we have a sports centre, and it has 1,279 members. So again, in practical, sample all of those people. So let's say we've got enough time to sample 166 people out of the 1,279. So doing that division, dividing the number you want to sample by the total, is going to be giving you the proportion we're going to be sampling. And typing that into a calculator is getting me 0.130 to 3 decimal places. And because my final answer will be rounded to a whole number, having a few extra decimal places in the calculation is going to help me keep a bit of accuracy here. And as a percentage, just to make it a bit more understandable, this would be 13%. So we're going to be asking 13% of the people who go to the sports centre. Now, again, to make this fair, we're not just going to ask 13% and just pick random people. It's going to be 13% of every single identifiable group. 13% of the men, 13% of the women. 13% of the male 0 to 18, 13% of the female 66 plus, 13% of every single group. So how do we do it? Well, we're being asked how many male age 19 to 65 we're going to be sampling. So we need to identify that number first. So we go to the male column, we go to the 19 to 65 column, and we see where they cross over. And it's 450 people at that sports centre, men, and they're in between the ages of 19 and 65. So we take that number, 450, we multiply it by the proportion we need, which was the equivalent of 13%, and 13% of 450 is 58.4. And again, like the last question, we are not going to be able to ask 0.4 of a person. We can only ask whole numbers worth of people. So rather than writing 58.4, we can just round it to 58. We're going to be asking 58 men in between the ages of 19 to 65 what their opinions are on whatever data it is that we're gathering. And it's not just that, we'll also be asking 13% of all the other groups as well. We've only been asked to work out one. Now for question 3, we have another school. It's a larger school this time, it's a secondary school. The school has 1,175 students, and we want a sample of 59 of them. So we divide 59 by 1,175, and that's giving me 0.050 to 3 decimal places, which if you multiply by 100 for a percentage, that's going to give us 5% of the total we're sampling. Now, as usual, this is a stratified sample. It's not a random sample. We're not asking people at random. So for a stratified sample, we're being asked how many Year 8 girls should be sampled. Now, we are going to sample every single year group. We are going to sample the boys as well, if we're actually doing this. But just to make the question a little bit easier for you, take less time, just to test your skills, rather than try and design the entire thing, we're only being asked about one actual part of the sample. And Year 8 girls, that's 123 people. So we take 123, we multiply it by the proportion we worked out, or alternatively, we're finding 5% of it, and we work that out on our calculator. And I'm getting 6.176. And we can't ask 6 and a bit people, so we're going to round it to the nearest whole number. We're going to be asking 6 Year 8 girls what their opinions are. And again, as you can imagine, asking 6 people rather than the full 123 is going to take a whole lot less time. Now for question 4, we are sampling 101 people out of 842 at a sports centre. So we type that into our calculator, and we should be getting 0.120 to 3 decimal places. Again, to make it a bit more understandable, as a percentage, that would be 12%. Now, we're not actually designing the whole survey, we're just testing our math skills, so we're only going to find one part of the survey. We're being asked for men in between the ages of 19 and 65 again. So we find that number in the table, it's 268. So we take 268, we multiply it by the multiplier we found, the proportion, and that should give us our answer. And I'm getting 32 people, and again, I've rounded that number down. So we're only going to sample 32 men in between the ages of 19 and 65. And now for question 5, we're sampling 93 students out of a full school of 1,852. And the proportion that should give us is 0.050 to 3 decimal places. Now, this time we are sampling its Year 8 girls. So we find Year 8 girls, there's 192 of them. So we take the 192, multiply it by our ratio 0.05, and we should get how many Year 8 girls we're going to sample. And by doing that multiplication, I'm getting 9.6 girls. Now, I can't ask 9.6 people, so we're going to round this nearest whole number. And this time, the nearest whole number is rounding up to 10. So we would ask 10 Year 8 girls what their opinions were. Now, the medium questions start off the same way as the easy questions. So we look at our data. We've got a school. We are sampling 56 students, and it's out of the total of 403 students. And then we divide those to find what proportion we're sampling. And it's 0.1 140 to 3 decimal places. So again, multiply by 100, it's 14%. Now, where this differs is we're being asked how many boys should be sampled. So when we identify that, we've got our year 1 boys, okay. We've also got year 2 boys and year 3, 4, 5, and 6. So this time, we're kind of looking at the entire group and how many the entire group is sampling. So what we need to do now is add up all of the boys and find out how many we've got. So we're doing 33 plus 32 plus 34 plus 35 plus 35 and plus 33. And adding all of that up, we've got altogether 202 boys. Now we know how many boys we have in total. You can multiply that by our 14%, and then we'll know how many boys to sample. And that is, I'm getting 28.28. So again, we're going to round out a whole number. We're going to be asking 28 boys what their opinions are. Now, while we have not entire groups by just identifying single parts of it, well, it might be that while your data is broken down into year groups, you're not actually too bothered about which year group the boys you're asking are in. So it might be you're going to ask 28 from randomly throughout the year groups, and you're not too bothered about each one being the exact 14%. So it just gives you options with a stratified sample on how many groups you actually do identify. You don't need to use all of them if you don't think there's a reason why you need to. For question 2, we are sampling 62 members of a 1,032 member sports centre. And we do that division, we're getting 0.06. So again, multiply by 100 to understand this. We're asking 6% of the people who go to the sports centre. Now we identify what we're looking at here, and last time we were asked for just all the boys, but this time it's being asked for people who are over the age of 66. So we've got the 40 men above the age of 66. We've also got the 89 women, so we have to add those together. So we do 40 plus 89, and altogether we've got 129 people who are over the age of 66. Multiply that by our percentage, multiply by 6%, and we'll get how many in that age group we're going to sample. Now I'm getting 7.74. We're going to have to round that up, so we're going to ask 8 people in that age group. On question 3, we are sampling 29 out of 357 students in a school. That division will get us 0.081. So we're sampling at 8.1% of the students. We're being asked how many girls are being sampled. So like before with the first question, it's going to be the girls in every single year group. That gives us 6 numbers to add up. The 29, the 28, 27, 30, 31, and another 31. So altogether, we have 176 girls. Multiply that by our proportion, and that's going to give us 14.25. So rounding that down to 14, we'll be asking 14 girls. Moving on to question 4, we are sampling 183 students in a school of 1,664 students in total. That gives us a proportion of 0.110 to 3 decimal places. Now we're being asked how many girls should be sampled again. And this time, secondary school, it's only got 5 classes, from year 7 up to year 11. So we need to be adding up those 5 numbers to get the total of girls. So use a calculator if you've got one, it's nice and fast. If you don't have a calculator, maybe it's a non-calculator question, then you can use a column method. And altogether, I'm getting 814 girls. So multiply it by the proportion, finding roughly 11% of them, and I'm getting 89.54. So I'm going to have to round that up. So we're going to sample 90 girls altogether. And now for question 5, we're sampling 101 students in a school with 1,009 students. And doing that division is going to get us 0.1. Now there are some more numbers on my calculator display, but it's 0.1000. So effectively what we're doing here is we're finding 10% for our sample. Now being asked how many year 11s we're going to sample. And for year 11s, we've got 101 Year 11 boys, and we've got the 110 Year 11 girls. So if we add those together, we should be getting 211 students. And finding 10% of that, maybe do that in your head. 10% of 211, it's going to be 21.1. So it's the nearest whole number. It's going to be 21 students we need to sample. Now, the hard questions are examples of reverse questions, and this is because we've not been given a total for the first question. It's a sports centre, we've not been told how many people go to the sports centre, and we have partial information in our table. We have all the breakdowns for ages for men, but for women we've only got 0 to 18 and 66 plus. So we're missing how many people are in that 19 to 65 group. Now, on other questions, we were kind of starting off finding the proportion that was sampled, and we can still find that. And it's because we've been told that 12 out of 128 male 19 to 65s were sampled. So we can do that division and work out the proportion that was sampled, and it is 0.094 to 3 decimal places. So again, multiply that by 100 to get a percentage, just easier to understand. We've sampled 9.4% of each group. Now, for our next step, we're being asked how many female 19 to 65s were sampled. Well, actually, we've been told that 34 have been sampled. So we're kind of working backwards from the sample to find the original total. Now, what we did in previous questions is we took the number we were given and we multiplied it by the ratio. And that's when you're working from the total to your sample. But this time we're working from the sample to the total. So it's the opposite way around. And because that's the opposite, we're going to do the opposite operation. So we're not going to multiply by our ratio, we are going to divide by that ratio. And so we're going to do 34 divided by 0.094. And that's giving me 362.6 recurring. Now, that answer doesn't make any sense. How can we have 0.6 of a person? It doesn't make any sense, we can't have it. But what you might remember is in the easy and medium questions, when we did our calculations, the sample didn't always give you a whole number and you would have to round. So that original 34 we were given, that's not actually the accurate number for the sample. We should have been sampling somewhere around about 34, a number that rounded to 34. So what we need to do is just do the same thing again, round it to the nearest whole number. So we're going to round that up, because 0.6 is more than 5, rounding it up, and that'll give us 363 as our answer. And then you can test that out to make sure it makes sense. So you had 363 people, and you multiply it by 0.094, so just working backwards now back to that 34. I don't actually get 34 on the calculator screen, I get 34.122. So really the question should have said we're sampling 34.1 female 1965s. Because it's impossible to question 34.1 people, it was rounded, which then meant our answer was a little bit off. So we had to round that to compensate. Now the whole reason why we could do that is because we got the 12 out of 1 to 8 clue in the question. So for question 2, the first thing to do is find that clue. And we've got 54 out of 4,627 were sampled. So that's our clue to find our sample ratio. So 56 over 4,627. There's always going to be one item of data where you know the sample amount and you know the total amount for it, just so you can work out your ratio. Now for the easy and medium questions, you need the totals, so the sample amount for the total and the total for the total. But for these questions, it's just one item of the data we've got it for. So doing that division, we're sampling 0.012. Now, what are we being asked for? Well, we're being asked for female 0 to 18s, and we have a clue for that 61 of them were sampled. So we take our sample amount, 61 were sampled. We take the proportion that were being sampled, 0.012. Again, because we're working backwards, it won't be multiplication this time, it will be a division. So 61 divided by 0.012 And that is giving me as an answer 5,040. Now I've got 0.125 on the end as well, and again we can't have 0.125 for the person, we can only have whole people. So we're going to round it to the nearest whole number, so 5,040 will be our final answer. The reason why we're rounding is because the 61 we're given as a clue in the question. That number itself has already been rounded, which introduces a rounding error. So we're working back towards our answer, just realise we need a whole number answer we can round. So moving on to question 3, looking for a complete set of data. We're looking for a sample number and a total number, and we have it with the 8 out of 80 year 10 girls. So if we do 8 divided by 80, that division should get you 0.1. We multiply that by 100, we get 10, so we're finding 10% of each category. Now we're being asked to find how many year 8 girls there were in total, and that piece of data is missing from the table. And the only way we can find it is if we have a clue, and we do have a clue for year 8 girls. 9 of them were sampled. So we take our sample number, we divide it by the ratio, working backwards to the original number, and that should give you 90 exactly. So there should be 90 year 8 girls written in the table. Moving on to question 4. Firstly, we need to find a complete set of data, and we have 9 out of 87 female 0 to 18s were sampled. That's a complete set of data with our sample size and the total number that was sampled. So from this, we can find out our ratio, and it's 0.103, just to 3 decimal places. Now, some of the data is missing from the table, and it's female 19 to 65s. So that's what we're trying to find. We can't find it, it's impossible unless there's a clue, and we do have a clue. 7 of them were sampled. So we take 7, we're going to work backwards, we're going to be dividing, and we're dividing by the proportion that we found. And if we do that calculation, 7 divided by 0.103, I'm getting just under 68. I actually have on my calculator display 67.96. That's very, very close to 68. So the missing part of the table, we could write in the 68. And so using that method for the final question, we find our complete set of data. 5 out of 45 were sampled, and this will allow us to find the proportion sampled. And that is 0.1 recurring. Then we'll look at what we're being asked for in the question. We're being asked for the number of year 2 boys sampled. We need to know something about year 2 boys, and we do. 6 of them were sampled. So if 6 were sampled, we can work backwards to the total by dividing it by the ratio we found. And 6 divided by 0.1 recurring. To calculate, you can just write 0.11 and type out 561, so that'll do the job. I'm getting exactly 54. So the blank part of the table, we could fill that in with a 54.
Ouch! This is why in some videos I explain scratches.